So we are in section 1.5 and we've been talking about slope. And now we're going to talk about slope as a rate of change, and we're going to look at an application problem. So what you should do when you approach these application problems is you should take a look at them and you should read through them once and then read through it a second time and kind of highlight the important facts that you think you might need and kind of highlight what's the question that they're asking. So it says in 1990, 9 million adult men in the US lived alone. In 2008, so this is later, 14.7 million adult men in the US lived alone. So the number has grown. Use the information to find the slope of the linear function representing adult men living alone in the US. Express the slope correct to 2 decimal places and describe what it represents. So we are looking to find the slope of the linear function that is representing the adult men living alone. I also need to take that answer, express it to 2 decimal places, and I want to describe what it represents. So I'm going to write a sentence about what it represents in the end. What important information, how can I find a slope? Well, I know that in order to find the slope, I'm going to use the slope formula. Now remember, the slope formula is given to you on your formula sheet, so you do not have to memorize it, but it looks like this. It's the difference between the y variables divided by the difference in the x variables. So we need to find, in order to find the slope, we need to identify some x and y variables. So at the beginning here, it says in 1990, we had 9 million adult males living alone. In 2008, we had 14.7. So I'm going to use that information to help me find the slope. So let's write out those variables. We have 1990 and then 9 million. Now we're going to keep in mind that the x variable stands for the year. The y variable stands for, it's not 9 people, but it's 9 million. So the units here are millions. And then we have 2008 and then 14.7. So those are my two sets of numbers, and I'm going to write them as ordered pairs. And now I'm going to use that to help me find the slope. I'm going to label, when I find the slope, you want to label them, x1, y1, x2, y2. And remember, it doesn't matter which one you call the first set and the second set, because in the end, it will still work out to the same. So I'm going to plug that information into my slope formula. Y2, so this is why it's important, because I want to make sure that I put the right number, substitute it in for the correct variable. So 14.7 minus 9, y1, x2 is 2008, and x1 is 1990. So I've put everything in the correct spot, and now I'm going to put this in my calculator. So I'd like you to pause and put this in your calculator, pause the video, and see what you get in your calculator. Now, it's important when you're using the TI-84, 83 graphing calculator, and even the TI-30 that you surround the numerator with parentheses and the denominator. Because if you write this as it's shown here without any parentheses, then your answer is going to be incorrect. Because let me show you. If I write this, and it's nice that with these calculators you have the large display because you can do this all in one step and let the calculator do the work. However, if you write it like this, the calculator is following the order of operations, and it's going to do the division first here, and then it's going to do the subtraction. So in order for us to tell the calculator what to do, we need to put in parentheses. So we want to put a parenthesis in here to tell the calculator that's the numerator, And then we want to close that parenthesis at the end of the numerator, and we want to put a parenthesis in here, and then 1 at the end. So now you should have got 0.316 with a run-on decimal. So let's write that on our paper here. Now, the problem here asks us to round to 2 decimal places. So 1, 2. I want to end it here, but I have to look to the right one. And when I look to the right one, I see that that number that I underlined is 5 or greater. If it's 5 or greater, you have to round that number with the arrow up 1. So we add 1 to that, and we would end up with 0.32. So this is my answer here. But I don't want to stop there because I do have to describe what this means. And so in order to help you describe what this means, what you need to do is take a look at the units. So go back to the problem and recall what the units were. On the top here, we said that the 9 and the 14.7 were millions. And not just millions, but what millions of what? Millions of adult men. And in the denominator, this was the years. This represented the years. So I'm going to say that the 0.32, it's 0.32 million every 1 year. So there's an increase. This is a positive number. The number of adult men that lived alone increased at a rate of 0.32 million. And there's no denominator here. So it's like you have a denominator of 1. And so it would be million per each year. So I'm going to write it out for you. The number of adult men living alone increased at a rate of 0.32 million per year. So this would be a description of what the slope represents. Now, we talked about function notation. If you have a function, sometimes the function is not linear. And so we want to think about the slope as a rate of change. And so this is entitled the average rate of change of a function. And so instead of using the notation of x, y, they're using the notation of x, f of x. So they replaced the y with f of x. So it's asking, you have the first, instead of x1, y1, it's x1, f of x1, and x2, f of x2. And it's just saying you've got 2 points on this function. So it's not necessarily linear. It's just 2 points on this function. And if you want to find the average rate of change from the first point to the second point, you're going to use this formula. This is called the average rate of change, or we can abbreviate it like this. And again, but it's the same thing. It's the same as the slope formula, just y2 minus y1. They're just using that function notation. It's the same thing. It's the change in the output divided by the change in the input. So if we flip to the last page of this section, we're going to see a problem that involves this. So the question here says, find the average rate of change for this function f, and we have the function f is f of x is equal to x cubed. That's not a linear function. If you were to graph it, you would see it's not a straight line. And it says from x1 to x2. So on the previous page, the average rate of change formula looked like this. Or again, think of it, just think y2 minus y1. The reason, because it's not linear, they call it this, but you can think of it, it's the change in the y's divided by that change in the x's. Do we have the y's here? No, we don't have the y's. We don't have what the function is at x1, and we don't have what the function is at x2, but we can find it. The reason why we can find it is because we were given the function itself. Here's the function. So what I want to do is make myself a table. And, oh, I called it y, but I'm going to change that back to f of x. So input output table. And when I input -2, what is my output? So if I was to take the function and plug in -2, that means wherever there's a -2, or I'm sorry, wherever there's an x, I put in -2. -2 times itself 3 times will result in -8. And then I do the same thing now with 0. So I take the function and I'm going to plug in 0 for x. 0 cubed will be 0 times 0 times 0, which is 0. Now I have an xy point, and I'm going to plug it in here. And let me write them up here so I have them right in front of me. When x is -2, the function output is -8. And when x is 0, the function output is 0. So into this problem, here is f at x of 2. So that's 0. That's going to go here. Here is the function at x sub 1. It's -8. That's going to go here. Here is x1. That's going to go in place here. And lastly, here's x2. And that's going to go here. So I'm going to plug all of that in. I'm going to say average rate of change. And what I like to do is put those blank spots there because it helps me sometimes when I have negative signs so I don't mix up what a negative sign is. So here I've got 0, minus the negative. Sometimes it gets a little confusing. So if I put the blanks in there, then when I put in the negative sign, I see 2 negatives, and then I know minus a negative becomes positive. And then x sub 1, -2, and then lastly, x sub 2 is 0. So I've got this set up, and then you can do it by hand. You would end up with 8/2, or you could put this in the calculator, just 0 minus a -8. Close the parentheses on the outside here, close the parentheses here, and we would hit enter on the calculator, and we would see the average rate of change here is 4. So given 2 points on any function, you can find the average rate of change using a formula very similar to it. It's the slope formula, right? Just written in function notation.